Hi, in this video we'll cover 3 examples of vector including 1.18, 1.19 and some extra question that I add as well as 1.20. So if you want to try first, please pause the video now.
2,000 years later.
Okay, the first question. Remember we are now trying to do the vector addition problem with algebra, not graphical anymore. So in general, let me tell you the main plan and steps first. So the first step you want to do is to decompose the two vector into vertical direction and also horizontal direction. After that, probably in these two situations, then it will be like this and this for A and B. Actually, you can draw like this, right? That may be more accurate. So this is how you can decompose it. We can calculate later on. After that, since you have two vertical and two horizontal, you want to find the net net magnitude of that two combined together. And afterwards, since you have got the net vector for vertical and horizontal, then you have to combine them to find the resultant vector. Okay, so that's the plan. Okay, let's start. So I would say the vertical sum, I'll call it R. So since R is the resultant, so Ry is the vertical of the resultant, would equals to this vertical going down. So I would call this as negative. So negative for this one is gonna be A, or actually A we know is 12 and B is 24. So let's just put it down as 12. This is signed. Alright, if you can't read this, actually you can do this and this, alright, as well as this and this, right? It's okay. So 12 sine 45 degree, and this vertical one would be also negative, or you can say plus a negative 24 sine 30. Okay, and then you can calculate later on. Because of the time, I'll do x first. So horizontally, since this side should be positive, so we have this side first, 24 cosine obviously, and the other side will be negative, so you can say plus a negative 12, which is A, cosine 45 degree. Okay, so just use your calculator and you can find out the value of these two first.
A few moments later.
Alright, I just find out I make a very stupid mistake, and that is not reading the question properly. In fact, what the question asks us to do is to find the component. So just we have to do is just decompose the two vector, vector A and vector B, horizontally and vertically, along x and y only. And that's pretty much the components that I find. All these four will be the answer. So I thought we have to combine it, so never mind, let's just change the question and we're going to continue with that. Okay, so what you get as the answer will be negative 20 something and 12 positive something for vertical and horizontal. So one thing you can do if you want yourself to be more self-aware of what's happening, then you can draw a vector like this, negative 20.48. I would prefer to take all the decimal point because this is only the intermediate step. You want to only round up at the last step only. And then for x is going to be going to the right, so that's going to be Rx. Actually, I can just do it like this, right? Rx and Ry. So the resultant should be something like that, I believe. And so in order to find this, right, it's very simple because this is a right angle triangle, right? If you imagine like this is the Ry, then this is the right angle. And so if we want to find the magnitude of this, very simple, use Pythagoras theorem. And so Pythagoras theorem would be finding out the actual resultant R with these two. So if you like to write the steps, then you can write Rx squared plus Ry squared, which is negative 20.48, that whole thing, plus 12 0.29, that whole thing, as much as you can. And then you just have to calculate your answer with the calculator. The answer should be about 23 point something. Okay, I will run this to 3 or 2, or depending whether the angle has a 0.0. Let's say 3. 23.9. Alright, I don't think there's any unit, yeah, just arbitrary unit. So 23.9 will be the final answer. However, we haven't finished yet. Again, I know the question didn't ask me to do that, but normally when you find the resultant, you also need to find the direction as well, because you are doing a vector addition, so you need to express the angle as well. So as for the angle, since supposedly here should be the origin, and so I guess one angle that we can find easily will be this one. Okay, and since that once again this is Ry, this is Rx, so if you think about trigonometry, then you'll be able to express tangent theta as Ry over Rx. Okay, and you just have to find out the arctangent of Ry and Rx. So I'm not going to write that long numbers again. So using your calculator, you can find out the answer to be something like this, negative 59.0. Okay, and that would be the answer, degree, let's not forget. Okay, so that means theta will be like 59 degree, but since normally we'll take, imagine this is the xy axis, then this is like 0 degree, then going in the clockwise direction, yeah, clockwise direction will be going for negative. For the second question, if you already studied the chapter 2 mechanics in IB, then surely you have already learned this, so you can just see if my answers is the same as yours. If you haven't, I would like you to refer to a video of mine in chapter 2. I'll put a link in the description below. For the answer, in the original example, we should have the W in this direction as W cosine theta, and this direction as W sine theta. Okay, one thing that I want you to pay attention to is the length of your arrow. Okay, so you should be forming a rectangle like I did here. As for part A, it asks you, which is designed by myself, it asks you to draw the free body diagram of the block. So be careful when you are asked to draw free body diagram. You should not be expressing anything that you got decomposed into. So that is to say, you should not be doing W sine or W cosine theta. You can only do the original force, the force that you start with. And here, of course, that will be weight, and there should be reaction force also. I don't know whether it would slide or not. So if we try to look at part B, that is in equilibrium, then there should be a friction, right? Which the block normally would want to slide down because of gravity, of course, and more precisely because of W sine theta. But since it is in equilibrium, then there should be a friction which should point upward, like up as in along the inclined plane. So I'll call it F here. For part B, if you have learned again in chapter 2, then you should know how to do it already. So the way you do it is you want to construct the two equations. So basically one is parallel to the plane. So along this direction, then friction should equal to the one that is dragging the box down, which is, like we said, W, or you may put mg if you like to, sine theta. And for perpendicular to the plane, then it's gonna be the reaction force and the other force, which is W cosine theta. Alright, example number 3. This time we really have to find the sum of the two vectors. So one is in the units of 8, one is in the units of 12. Alright, so the first step is to find each of the horizontal and vertical sum. So for the result, I'll call it F simply, and x represent horizontally. So I have f2, which is 12, and horizontally should be cosine 28. And then f1 actually going the other way around, so there should be negative, and 8 cosine 42 degree. Okay, so once again, I would do the calculation later on. For vertical, both of them are going up, so doesn't matter which one go first. So 8 sine 42 and 12 sine 28 degree. Alright, so just press the calculator. Alright, so the answer will be 4.6 something and 10.9 something, and the next step is to combine them once again. So, or if you like to, you can draw how it looks like first. So Fy will be something like that. This can help you to determine the direction more visually, so you can double check with your answers later on whether or not it's positive or negative. So for the sum magnitude, again we use the Pythagoras theorem. So we have fx squared fy squared, which I will still write again, square plus 10.9, that one, square. So again, press the calculator. We should get something like 11.9. So 11.9303, and I will round it to probably 2 this time. Yeah, probably 2 only, so 12 unit. So I guess, yeah, I think that's arbitrary unit. So I can just actually put down unit. Again, let's not forget you have to find out the angle as well. So probably is a positive angle for sure, right? Theta. So once again, you should have tangent theta, if this is a theta, then fy over fx, and so tangent will be arc tangent of that two number. Okay, I really don't want to write this again. So again, calculator, you should get an answer like 67.0 something. And I guess I'll take 2 suffix, so 67 degree simply. Okay, so that's all for the 3 examples. In the next video, I'll simply just go through all the rest of the question on the question set. So you may want to try first before you open the next video. I will see you again in the next video. Bye.